Like me, you've been wondering if the smoke points of your cooking oils are determined by their viscosity. Let's build a viscometer and find out. You'll need some small diameter clear piping, a small funnel, and some way to mount it vertically. It'll take some trial and error to get it all together. It's kind of a mess here, but I had to use rubber bands and duct tape. Once it's all put together, we'll measure the time it takes for the fluid to travel half a meter and use that to calculate viscosity. Everyone knows the viscosity of water is 1.016 times 10 to the negative third Pascal seconds. So let's use that to figure out a calibration coefficient for our apparatus. Water moves real fast. I had to slow the motion of this video down 16 times to see that fast flow. Now here's all the oils we're going to look at. Something I learned is that oil is messy. I did 3 trials for each of the 6 oils and calculated their viscosities. The data shows oils with higher viscosities tend to have higher smoke points, and that there's a linear progression. But note the exception. Corn oil is less viscous yet has a high smoke point. There must be other chemical or structural factors in the oil that's influencing its viscosity and smoke point independently. Now, a quick check of the Reynolds equation. Yep, looks like we have good laminar flow, way less than 200. Now we're done. Let's take apart our viscometer. This goes in here. Throw this away. And we're all set. Have a great day and feed your chickens.